conditions. Under acidic conditions, it was our other general mechanism. Let's use the same compound, acetone. Now let's treat this with just generic H3O+, and there'll be water around. When in doubt, under acidic conditions, we'll protonate the carbonyl group. Let's just put the lone pair there. Now we've made this oxonium ion, which is a much stronger electrophile, so that now water. This one I'll actually, I'll have it attack there as well. It's going to attack, but we'll flip. Whoops. It's supposed to be the other arrow. OH. Here's our water. It had attacked. We'll put the lone pairs in here for completeness in this one. And then now what we need to do is to take a proton off. We'll write water out in this case to regenerate our hydronium ion, H3O+, and generate our final product. Hydrate. I'll put it down here, H3O+. Okay, so that's the hydrated form under the acidic condition. So our other general mechanism we can always see. And this is for the last time here. Notice now under acidic conditions, positive formal charge, positive, positive, positive formal charge. So those are those mechanisms that we're going to see over and over and over again. And just as in a kind of a bit of an aside is, we mentioned earlier that aldehydes are more reactive than ketones. This hydration reaction sometimes is a nuisance. So the aldehydes are very easy to hydrate. And in the life of a synthetic chemist, this is oftentimes a big problem. So if we have something like formaldehyde, so the most reactive aldehyde that we'll have there, this one in the presence of water and even just with a little bit of acid or base is going to form the hydrate, which looks like this here. If there's just the smallest amount of water around, the hydrate is going to be in the hydrated form 99.9% of the time, and really only 0.1% in the aldehyde form. So if you're carrying out a chemical reaction where you actually needed the aldehyde, because now you have your electrophilic center, only 0.1% of your compound is actually in that form that you want. So what you really need to do is to dry it, try to get rid of as much water as possible. So if you're working in the lab with aldehydes, it's oftentimes very difficult because you really need to exclude water because they have this hydrated form. It's so easy to make. And also, if you ever have worked with formaldehyde in terms of preserving samples, like in a biology lab, formaldehyde itself, this compound itself is a gas. However, what you normally work with is a mixture. It's this species, which is known as formalin. And so there's a little bit of water in it. So the formaldehyde, it smells bad. At least I think so. That's used to preserve things. It's more of the formalin species. Totally irrelevant to any of this, but there's other aldehydes, though, some larger aldehydes. They actually smell really good. I wouldn't encourage you to just smell them. You have to waft, of course. But they have a lot of nice fragrances have aldehydes in them. All right, so interesting, yes. And so I don't know if anyone's had to work with formaldehyde. It reminds me, like, I think I was in 7th grade, and we had to dissect some poor earthworm in science class. But maybe that's why I went into chemistry and biochemistry. Oh yeah, cinanaldehyde does. You kind of like it. Okay, formaldehyde. Yeah, that's not. You do get used to it. The worst thing was, and I know we have a lot to cover, but this is a story time. When I was a graduate student, so this was at the University of Chicago, where I